Folks, welcome back to the second video of the math series lecture. This video will consist of 6 topics, and before I start off this video, I would recommend you to watch the previous video. To start off this video, I will quickly recap all the topics I have discussed in the past video so that it makes little sense for you where are we heading. Some of these concepts will be also discussed in this lecture as well. So in the previous video, we discussed about Riemann hypothesis, Kaika problem, twin prime conjectures, Maxwell's demon, Navier-Stokes theorem. All these were very interesting concepts I have detailedly explained in the previous video. I have linked it in my description, or you might find in the I button somewhere over here. Right? All these concepts are been derived from Terence Tao. He is a modern day mathematician, and I found all these concepts in Lex Friedman's podcast, where Terence Tao was one of his guests. You can go watch that video as well. Now, a quick disclaimer, I am no maths expert or not a maths professor. I'm just a curious soul trying to understand all these topics and trying to share my understanding and learning with all of you guys. So with that being said, let's jump in today's video and let's try to understand some of the coolest maths concepts across the world. Let's begin. Folks, the very first concept for this video is infinite monkey theorem. This theorem basically deals with two main concepts, randomness and infinity. We'll understand more about this as we progress towards the end of the topic. But the word infinite carries the whole idea of this topic. To start off with, let me focus on the question that is being displayed here. If you gave a monkey a keyboard, will it write the word Shakespeare? You might answer no. But mathematics says it's possible. Basically, randomness function and infinity function, how they behave differently and individually in the mathematical environment is what this infinite monkey theorem is trying to deal with. Now, let's understand this with a real world example. If a man is buying lottery ticket, he might or might not win the lottery at the first attempt. But if he is doing continuously for infinite times, do you think he will win lottery? The answer is yes. That's the same concept that has been applied with the monkey as well. It is being said that if a monkey randomly pressing keys, it can type all possible finite text, including the Shakespeare's Hamlet. Now, this concept is trying to deal with randomness and infinity, and it is said that it is possible, but it is not practical. Fun fact, if a monkey is sitting and typing all the finite text, it will definitely type over infinite period of time. But the amount of time it is going to take is far more than the universe age itself. So that's the reason we say it is possible but not practical. So mathematicians use this concept to understand infinity and randomness, and this is how they explain these concepts. So I hope you have understood this concept. If you have any questions about this, please drop down. And with that being said, let's move to the next concept, which is linked to physics, and it is somehow trying to make an understanding of mathematics as well. Let's jump in. The next concept is spherical cow metaphor. It's a physics-based concept, and the entire concept is lying in these two words, spherical and cow. So let's assume this box is cow. Imagine a real cow standing here with perfect legs, perfect tail, and all this color combination on this body. Now for a moment, I'll remove this cow and I'll convert this cow for our understanding into this circle. I just simplified a very complex looking animal to a simple shape called circle. This is exactly what physicists are trying to understand. They basically convert any complex thing into a simplified format and only then add more details to it post their understanding. So the entire flow for them looks this way. First, they understand reality, what the reality looks like. They simplify it, basically converting into a circle or maybe any form of understanding for their benefit. And then they break it down for their understanding and how well they can explain and observe it. Post that, they improve it, basically adding on more details to it. So once I understand this entire thing, I backtrack it. So maybe once I understood how a cow looks like, how a cow behaves, what are the characteristics of a cow, I'll convert it back to a cow because I have understood it. So the whole point is how physicists are thinking. This concept is basically trying to make you an understanding of how physicists are thinking and how they are processing these complex topics. So this is what the spherical cow metaphor is, and there's a very famous quote with this: all models are wrong, some are useful, by George A. Box. So this is the entire spherical cow metaphor. It's not a concept, it's just a metaphor I want to discuss, because when I was watching the Terence Top video, he mentioned about spherical cow metaphor. So I was little in the shock. Why did the word cow come in a mathematics video? So I wanted to dive deep into it. So I thought, why not share with you guys? I hope you find this interesting, and this is a very humorous way to say that physicists are trying to convert anything into a circle and circle to a cow. I mean, that's just a way to make you understand, but that's how this whole thing works. And I hope you enjoyed this. So next time, if you see anybody talking about spherical cow metaphor, you know what they're doing. They're converting a very complex thing into a simple thing, right? Now let's move to the next concept, and the next concept is related to prime numbers, something that we left back in the past video. It is again back, and I have something interesting to talk about prime numbers again. So let's watch. Prime numbers theorem. I've discussed about prime numbers in my previous video, and this theorem has been the inspiration for Riemann hypothesis. In fact, this theorem has been the greatest breakthrough in number theory. So to understand prime numbers theorem, let's first understand these numbers: 2, 3, 7, 11, 5, 13. All these are prime numbers. And the whole agenda of prime numbers is that anything that is divisible by 1 or by itself is called as prime numbers. This theorem states that approximately how many prime numbers exist below any large number. You take any large number. For example, 600. This is a large number, and we need to find out how many prime numbers exist between the range of 0 to 600. Now, of course, you can't sit and write 2, 3, 5, 7 and go on till 600. That's a time consuming process and it doesn't work. So we use this formula: pi multiplied x times equals x divided by log multiplied x times. Will give you approximately how many prime numbers exist below any large number. Now, an exercise for you. Pull out a piece of paper and pen and try to figure out which of these range has maximum number of prime numbers. Is it 100 to 1000 or 1 to 100? And you can find this out using this formula. Now, I will bring up these problems in the later video where I will solve all these questions and pull up some questions as well to help you guys understand. And this is what prime numbers theorem is all about. But for now, you can explore more about it, and this is what prime numbers is completely about, right? With that being said, let's move to a very interesting concept that I recently discovered on Novel's podcast, and that is lined up the next topic. Let's go. The next concept is Erdős unit distance problem. It is discovered by Paul Erdős, and I discovered this question on Novel's podcast, where he was discussing about this as Irish math problem, and that's when I understood this in a deeper way. Now, for now, I have just a brief of this entire problem. I bring up this concept later because this concept is a little on a trickier side, and this is what Paul Erdős says, that he loves problems which are understood by children but not by mathematicians. It is very difficult to solve by mathematicians. This question is even today the most famous question in combinatorial geometry. And the whole question is that you see a bunch of dots on the board, and all the dots are assuming 1 meter apart. I have mentioned here 1 meter apart, all these dots are. The question for you is how to arrange these points to get maximum number of 1 meter connections. To define it in more Paul Erdős term, given n number of points, what is the largest number of pairs exactly 1 unit apart is what you have to try to understand and try to find out from Paul Erdős unit distance problem. Now, it is said that for past 80 years, mathematicians believe that a square grid format is the best way to find out the maximum number of pairs of 1 unit distance apart points. And that's how they're trying to arrange these points in a square grid format. But recently, OpenAI's model itself has disproved this. and you can study more about it. I will link that paper down below in the comment section. Maybe you can dive deep into it and how OpenAI has solved this problem, and they have disproved that this format is not right. Now, just a fun activity for you guys. You see here random points, and all this again are 1 meter, are 1 meter apart. How do you arrange them? It is said that geometry itself creates an equal distance and completely equally spaced points. Now, this is an hexagon shape if you observe properly. Geometry itself has formed this equally placed points, and all are perfectly balanced, is what Erdős unit distance problem is. You can study more about it. As said, I have just given you a brief of this problem. You can dive deeper into this, and the whole gist is this entire thing. It is a famous problem, and I'll bring this problem later as well. There are a lot of concepts I want to bring up a later video as well, maybe a part 2 of the entire lecture of all my lectures, and I will combine everything and maybe try to solve a single question as well, to question my own understanding and also share my knowledge with you guys. With that being said, with Paul Erdős unit distance problem, let's move to the next concept. So the next concept is Plato's cave allegory. Plato is a very famous philosopher. You can Google about him. And this concept is a very simple concept, but just a understanding and just a POV of how things work here is what I want to make you understand. Again, this was discussed in Terence Taw's video. So it's a very simple concept. Assume this is a prisoner and he's locked into the prison. All he can see is the shadow of a wall. Now for this person, the entire reality is this shadow. He believes that the world consists of only shadow and there's nothing else apart from the shadow in the entire universe. Now one day what happens, this prisoner escapes and he goes out and sees sun, he feels wind, he sees stone, he sees plant, etc. He's confused for a while, he's trying to process what he has seen, and he goes back and tells. Now what is happening is that there is a complete difference in reality and true knowledge, is what Plato's cave allegory is completely trying to depict. So this was Plato's cave allegory. It's a very huge article. I'll link it below. It's from Wikipedia itself. They have explained very beautifully how this Plato's cave allegory is. But the entire concept is trying to have an understanding between reality and true knowledge. That's the whole concept of Plato's cave allegory. I hope you've understood Plato's cave allegory, and I'll move to the next concept. Last concept for this video is Euler's identity, one of the most interesting and beautiful formulas ever existed. So it states that e to the power of I pi plus 1 equals 0, where E stands for growth. Anything. You invest money, you earn interest, your money grows. Growth of bacteria, growth of virus, growth of population, everything is linked to the term E, where I is imaginary number, pi is circle, 1 is identity number. Anything multiplied by 1 remains 1 itself, and 0, it's basically a term that represents, and there's no value at all. Zero coins means nothing, 0 pizzas means nothing. Exactly, this entire things comes together and gets clubbed over here. Now this is not the magic and this is not the beauty of it. The beauty of it lies over here. All concepts of geometry, calculus, trigonometry, algebra and complex number come together in this single formula. Without this, any modern day engineering is failed. Your MRI machines, your computer graphics, your ACs, your cables, your semiconductors, everything is failed if this formula doesn't exist. And that's how interesting this formula is. Now this gets more magical, not here, but at this place. E to the power of ix equals sin x plus I cos x. This is where the entire formula gets more interesting. And basically we have assumed some terms over here. We have replaced these terms and we have assumed in sin x and cos x terms. This is a very big concept, but as I said, I'm just briefing you over here. I'll be bringing this concept later as well. And maybe in the future videos, I will bring up this concept and explaining with a real world example. Maybe a modern day engineering, maybe for example, computer graphics. I'll take up and I'll try to relate that computer graphics with Euler's identity. That will be a single dedicated video only for Euler's identity. I recently also saw this video, of this concept on Figma's conference when 3 Blue 1 Brown was discussing about this exact formula on his conference talk. So maybe you can go watch there as well. He has explained it very well, and even on his channel 3 Blue 1 Brown, this entire thing is explained very detailedly. So I'm exploring more and exploring in more depth so that I can explain you better. That is all for today. That's all for today I have. Thank you so much for watching. I hope you like this video, and if you like this video, do subscribe, drop your comments. I'm trying my best to explain these concepts. It's new for me as well, and I'm exploring day by day these concepts and trying to get more understanding of this mathematics. As I said in my previous video, adulthood is all going back to maths and physics and science in general, so that I understand this well and make humanity better, right? The mission is simple: make the world a better place. That's all it is, and maybe maths is the only tool that can help me do that. Let's find out. And yeah, thank you so much for watching. I'll see you in the next video. Bye bye.